So, welcome everybody. Today I will talk to you about the Superhero Decentralized Exchange, or Superhero DEX, what we call it. And we've developed this product for the last 9 months, basically. We were trying to solve one very specific problem, and that's what I will talk first about. So I'll give you a quick introduction into the problem. And then we will explain, or I'll explain you the math that goes on behind the DEX so that you can confidently use it and understand what's happening. We're going to then talk a bit more about the practical parts. So we're going to talk about swaps, we'll talk about adding and removing liquidity, and I will try my luck with a live demo, so to prove that it works, and we will see how that goes. So the problem that we're trying to solve is we're trying to swap or exchange two commodities. And when we're talking about commodities, I've picked two random examples here, a banana and an apple. And when I'm coming to you with an apple and I want some bananas from you, how do you know how much bananas to give me? What's a fair price? And this has been a problem that humanity had for quite a long time, and they come up with a variety of solutions. And one of the most common ones that you see around is the so-called order book mechanism. This is a mechanism where persons or entities can come to a central place, submit a bid or a ask for a given price. So say, I don't know, I want to buy 2 apples for the price of 3 bananas. And a central place then aggregates all of these orders, and if there are orders matching, so if somebody wants to sell something for the same price that somebody wants to buy something, then these orders get fulfilled. But this also means that there is a lot of orders that do not initially get fulfilled and may never get fulfilled. And so the things is, when we are talking about these centralized systems and these central places, that there is always someone actively trying to solve these problems. So there's someone actively matching the orders in order to fulfill these. And this means that there is always something going on. And when we're looking at this in the sense of a smart contract, we ideally want this to happen faster, and we don't want to store all of the information. And so there is a different way to do it. And one of the other problems that we also have is that when you're submitting an order for a price that maybe nobody wants to buy or sell for, you might end up never getting your order fulfilled, or like weeks later. So it's just not a great user experience as well. So people came up with different solutions over time, and the one most commonly used for this on the blockchain itself is the format of a DEX, and the most DEXs use what's called an automated market maker. We'll go a bit more into details later on, but there's one famous example from another blockchain that we took some inspiration from, and then took it over to our glorious blockchain, and gave it a last polish and pushed it out. You might have seen something with a unicorn. So for those who've never used a DEX or seen a DEX, that's basically what it looks like. All you need to do is you punch in 2 tokens that you want to swap. The DEX, if there is a trading pair available, automatically calculates the price for you, and you can just press the button to swap the tokens. The transaction will happen basically immediately, and you will end up with the token that you're trying to swap. So it's really a click and buy system. You're not really submitting orders in the traditional sense, and this all happens with the magic of an automated market maker. So when we're talking about a very simple technical view, we have what we call a pool contract, and that's the thing where all the transactions end up at the end. and every pool contract holds two commodities. Here in this case, I just chose two colors, so we have a green commodity and a yellow commodity. And the idea is when you are sending in some green commodities, you will receive some yellow back. That obviously also works in the opposite direction. And the question is, how does the pool know how much it should send back? So when I'm sending in 3 green, how much yellow will I get back? Same problem that I asked in the beginning. If I'm giving you 3 apples, how much bananas will I get back? And the solution to this, as to many problems in the blockchain space, is math. So we are gonna take a little look at the math behind the DEX. The most important function that you will find in the blockchain, in the DEX, is the so-called constant function. And the constant function here basically resembles a multiplication of the two reserves that we have in the pool. So assuming we have, I don't know, 3 yellow and 3 green, it will end up being multiplied to 9. And then we have this constant function, and we at a fixed liquidity, so we start out with a fixed reserve, we will get a constant, and we will stick to that constant for every swap that happens in that pool. So what does that mean when we're looking at it graphically? You can see here I've drawn an example where on the x-axis you see the reserves in AE, and on the y-axis you see it in US dollars. And we're gonna start out here with one AE and 4 US dollars in the pool. So that means when we're looking at our constant function, it always has the value of 4, and we can just draw a smooth curve. And whenever we're doing swaps, remember, we want to stay on that curve. And so the question now is, what happens if we're sending in some tokens? So assume Alice sends in 3 AE. We will obviously, the liquidity that is now in the pool, or the reserves that are now in the pool, will move away from that curve. In order to figure out how much we will send in return, we can just draw a line down and return to the curve, and therefore we will immediately know how much we should send out. And this means that when Alice, in this case, would send in 3 AE, she would get 3 US dollars out. This allows us to do a bit more math as well, so we can find out the price of the execution when we're looking at the reserves before the swap and after the swap. We can just draw a line through the 2 points, and then we can look at the slope of the line, and this will allow us to get the price of the execution. This one is quite simple. We have 1 because we put 3 in, we got 3 out. But this will become interesting later when you are doing more swaps that look a bit more like this. So this is a more common swap probably, and you will see that we are doing just a tiny step on the curve. So we are staying roughly like within the same liquidity, we're just moving a bit, and so we're getting a smaller price of the execution. And so you will see that this here we're sending 0.1 in and get roughly 0.4 out, and the price of the execution is 3.5. And this is interesting because obviously what I showed you in the beginning is we have this UI and we immediately show you a price. So you punch in like 5 tokens and we will show you a price, and to determine that, the initial price, this helps quite a lot. If you're just interested in the price at a given point, we can also, that's what we call the marginal price. You can also look at the slopes of the tangents at the liquidity at the given reserves. So initially we had a marginal price of 4, and after the swap that Alice did, the big one, we ended up with a marginal price of 0.25, and this always reflects like the ratio that you would get for a very, very small trade. So I hope you grasped a rough understanding of the math behind it, and now I want to get into some examples on how we would use the DEX. The first example is just like basically doing what I just showed you in math and applying it to a more real example. So when we're sending in 3 tokens, there is this one thing that I haven't told you so far, which is a fee. And so with the math works out really nicely when you ignore that a bit. But here in the real world, obviously, for everything that you do, you kind of need to pay nowadays. And so we are also collecting a fee. We will show you why a bit later. But basically, we are sending in some tokens. We move the liquidity down the curve, and we can then determine how much tokens you will get back. And an interesting question is also, when I mentioned in the beginning that there would be a pool contract and there would be a yellow and a green token in it, the question arises is, what if there is no pool contract that exactly covers the pair that I'm swapping? So let's say I have a token A and I want to swap it to the token B, then we have the first case. We have a pair that covers that exactly for us, and we can just go there and do the swap and everything is perfect. But what happens if we don't have that pair? So I drew the second example where we want to swap token A to token C. And here in this case, we have 2 pairs that allow us to do the swap. So we are first swapping token A to token B, and then token B to token C. And this obviously means that with a low number of pairs, we can already gain quite a big number of potential swapping routes, because we can just consider it a full network. And finding the route through that network is not terribly trivial. So that's why we have a backend service in place that basically takes care of this specific problem, finding routes through the network that are the most optimal. Because if you remember the fee that you're paying, the 0.3%, you're paying that for every swap. So the more hops you're making, the more expensive your swap will become. But the good thing from a user side is you don't really have to worry about it, because we can all do it for you. So the same easy user interface remains. You just need to be aware that you might pay a little bit more. And technically this can be endless routes, but there is something called a gas limit that sets an end to this at some point, and probably your wallet too, because you want to get some money out at the end. So the question then comes, when I'm talking about these pool contracts, where are they coming from? Why do they exist, and whose money is in the pool? And we have another entity, not only the end user, but we have someone or some people or some entities called liquidity providers. And what they are doing is they are very, very nice people, and they bring some commodities with them, and they very graciously put them in the pool. And this means that whenever I'm adding or I'm acting as a liquidity provider, I need to bring both commodities. So I need to, in this case, going back to the color example, I need to bring the yellow and the green tokens, and then the pool will give me some what we call liquidity tokens in return. And these tokens are very specific to the pool and represent my share of the total liquidity in the pool. So say there is 1 green and 1 yellow token in the pool already, and I'm giving in another yellow and green token, so I'm then technically owning 50% of the liquidity in the pool, the pool contract would mint enough tokens so that I would own 50% of the total liquidity tokens in circulation. And the same thing obviously also works in reverse. So when I'm putting in when I'm handing back my liquidity token and the contract subsequently burns it, it will send me my share of the liquidity within the tool back to me. So why would you be so nice and provide liquidity on the DEX? Obviously, we are paying you for your efforts, and so there is a 0.3% fee that gets collected on every swap. And so this means that when someone sends some token in, as we saw in the example earlier, they either send in a bit more, so 0.3% more, or they just get 0.3% less at the output. And this means that the liquidity in the pool always keeps increasing. And when I'm then later on coming back with the liquidity tokens that I have, I get more than I put in. This sounds very easy. There are risks involved that you should definitely read up on. There is something very prominent called impermanent loss. I'm not going to go into too much details, but before you provide liquidity, please do read a blog article about it and inform yourself a bit. So it's time for the action part now. I will try to do a live demo of the DEX, and we will see how it goes. So I've opened the DEX here. You can find it at dex.superhero.com or app.dex.superhero.com. Perfect, you can see it as well. And you see that I'm already logged in here with my testnet account. And what I can do now is I can just go in, click, and you see that we have a couple test tokens available here that I can select from. So if I'm selecting AE, for example, here, and something else, let's say this one, then it will immediately quote me with a price that I can do, and now I could enter an amount and do the swap. But to make it a bit more interesting, we can just go ahead and I wrote I revived the old software that we had to generate some new tokens. So we can do a universe 2 token, and we give it the symbol, and we're just gonna mint, let's say, 1,000 tokens. So now it's going to ask me to assign the transaction, and there we go. We have a new AX9 token that I just minted, and I'm the only person that has balance on it. So if I punch it in here, it will tell me, hey, this is your AX9 token, so we're gonna import it and add it to our system. And it says I have 1,000 AEU2, but there is no liquidity pool for it because I just created it, so it's a bit hard for people to do swaps with it. So what do I want to do is I'm gonna go over and I'm gonna create a pool. You see, I already have a pool, but for this one we're gonna add a new one. So we're gonna go ahead and put in AE and our beautiful AE universe token, and now I can define the ratio. So let's do 10 AE, or let's do 100 AE, and use 100 AEU2. And now what it's asking me to do, it's asking me to approve the usage of my token. This is something that you may know from Ethereum, but basically, because the DEX is withdrawing the tokens on itself, we have to allow this transaction in the first place, and then it should approve it. Perfect. And now I can actually create the supply. And I will happily receive 100 AU AE pool tokens. So these are the liquidity tokens that I was talking about, and I have a pool share of 100%. So all the fees that are happening are going to me. Let's wait for the confirmation. Perfect. So, and now we can go over to the swap side, and you see that now I have a little bit less AE. I have a little bit less AU too, and the price is 1-to-1. So if I say I want to buy 10 AU2, it will just allow me to do a swap, and we can then do it. You will see that here my price impact is 10%. So this is like, if you think about the curve again, we're moving quite a bit here, but we will do it anyways because we're not too worried about, since we also get all the revenues. And there we go. I now successfully swapped this, and you can see I paid 10 AE, exactly 10 AE, but I got a little bit less than 10 AU. And this is because when we're moving the curve down just a little bit, we are receiving less, and also my fee got deducted from my output because I said I want to swap exactly 10. So yeah, that covers the live demo. Everything went well, so that's great. So yeah, all there is now. Feel free to try out the DEX on your own. I've linked the landing page here. And if you want, feel also free to create your own tokens, testnet, mainnet, yeah, and put them on the DEX and use it and do the swaps. Thank you.